Hello everyone. Today our group want to present about our case study. This subject is DCC 40152 Water Supply Engineering. So this is our group members. First, Muhammad Falullah and me, Xavier Uzina, and then Alfred bin Anthony, and lastly Nico Kenneth. Our lecturers is Madam Mimi Manisa Dohan. So now we move on to our introduction. So this case study is focused on how clean water is supplied and distributed throughout Polytechnic Kuching Sarawak. PKS located along a water distribution system that operates a water distribution system that supplies clean water throughout its campus area. This system is managed under the Sarawak Water Board, which is Lembaga Air Kuching Network. It ensures consistent water delivery for the academic buildings, workshops, laboratories, hostels, and cafeteria. The distribution network at PKS includes several key components, such as the water source, storage reservoir, distribution pipelines, pumping station, and control valves and meters. Each plays a vital role in ensuring that treated water is efficiently delivered to all facilities within the campus. The system ensures continuous and safe water supply to academic buildings, hostels, canteens, and laboratories. So, this figure shows the map that showing PKS location in Matang area. This is the location that we choose, which is located at Polytechnic Kuching Sarawak. Okay, next, PKS is located along Jalan Matang, estimate 12 km from Kuching City. The campus includes academic buildings, workshops, office, and hostels that require a steady water supply. Water is distributed internally through an engineered pipe network connected to the Sarawak Water Board main supply. So these two figures show our Polytechnic Kuching Sarawak, and beside it is our campus, hostel campus. So as we can see, the storage tank located at the rooftop of the hostel is supplied through the hostel so that student can get any water for daily life. Thank you.
Okay, now I'm going to talk about key component of system. Number 1 is water source. Number 2, storage reservoir. Number 3, distribution pipeline. Number 4, pumping station. And number 5, control valve and meter. For water source, the main source is Batu Kitang Water Treatment Plant operated by Sarawak Water Board. Raw water is taken from Sungai Sarawak Kanan, treated using coagulation, sedimentation, flotation, and disinfection. Treated water is sent through large transmission mains to Matang area, then supplied to PKS. For storage reservoir, PKS used an elevated concrete storage tank located near to hostel block. It balances the supply during peak usage and maintains water pressure through gravity. The tank stores sufficient water to support the campus during a short interruption. For distribution pipeline, the internal pipeline network distributes water to all facilities. Material is high-density polyethylene, HDPE, and PVC. The pipe size is 25 mm to 150 mm depending on flow demand. Designed in a grid pattern to minimize pressure loss and maintain even flow.
Next is a pumping station. A booster pump is installed near the reservoir to maintain adequate pressure. The system operates automatically using pressure sensors. Ensure sufficient water supply to higher floors such as academies and hostel buildings. Pump design follows the Bernoulli's and energy equation to determine head and discharge. Next is a control valves and meter. First one is gate valve, used to isolate sections of pipelines for maintenance. Second is pressure reducing valves, regulate pressure to avoid pipe damage. The third one is non-return valves, is to prevent backflows from the system. And fourth is water meter, is to monitor campus water consumption and detect leakage. Next is the diagram simplify the entire water distribution layout from the main water source to the final distribution point within the campus building. It starts from the Batu Kitang water treatment, which processes clean water. The water then travels through the main supply line to the Polytechnic's reservoir, where it's stored temporarily. From the reservoir, the booster pump active to maintain sufficient pressure. Next, the water flow through the internal pipelines to distribute it across all blocks and buildings. They include hostels and academic areas. Finally, the valve and meters are placed along the system to control the flow, regulate pressure, and monitor water usage. This setup helps maintain the balance pressure across the network and ensure no backflow occur. It's designed following a Bernoulli's principle, ensuring efficient heads and discharge control. So, overall, this diagram represents the complete water distribution system, showing how different components work together to ensure continuous and efficient water supply around the campus.
My name is Nicodemus Kenneth, 05DKA23F2020. Next, I will present about engineering concept that applied in this case study, which is hydraulics, storage design, pipe design, and pump selection. So for the first one, which is hydraulic, hydraulic is important because it helps make sure there's enough head and pressure throughout the water distribution system. So as you can see in this slide, you can see the flow rate is calculated using the formula Q equals A times V, which means flow rate equals cross-sectional area times velocity. We also use the Darcy-Weisbach equation to find out the head loss in the pipes. By applying these principles, we can ensure that water flows smoothly to all parts of the campus without losing too much pressure. For the next one is storage design. The storage reservoir is used to balance the water supply and handle in the peak demand period. This means when water usage is high, the tank can still provide enough water to all buildings. The formula we use is V equals Q times T, where V is storage volume, Q is flow rate, and T is duration. By designing the right storage capacity, PKS or Polytechnic Kuching Sarawak can make sure water is always available even when the main supply is temporarily low. Now we move to pipe design. Pipes are designed using the Hazen-Williams formula to calculate flow rate and head loss, and this helps determine the right pipe diameter and material so that the water flows efficiently. In Polytechnic Kuching Sarawak, the pipe network uses HDPE and PVC material which are strong, light and resistant to corrosion. Good pipe design helps reduce pressure loss and ensure a steady flow to every building. Next one and the last one is pump selection. For pump selection, the pump is chosen based on the total head and discharge requirement. This means we calculate how high and how fast the pump needs to push the water. At Polytechnic Kuching Sarawak, the booster pump helps supply water to upper floors like hostel and academic blocks. The design follows Bernoulli equation and energy equation to make sure the pump operates efficiently. By selecting the right pump, we can maintain stable pressure and reduce energy use. So for the last slide is conclusion. To conclude, the water distribution system at Polytechnic Kuching Sarawak works efficiently because of these engineering concepts, which is hydraulics, storage design, pipe design, and pump selections. All of these play an important role in ensuring continuous and clean water supply throughout the campus. By applying these principles, the system becomes more reliable, efficient, and sustainable for daily use.